Good afternoon. So, as the topic goes, satellite communication and navigation technologies and applications. So, I'll start with my talk today. Sorry for this delay. So, I'll cover basically the various aspects related to satellite communication and navigation as associated technologies as well as the application. As all of you are well aware of, ISRO space program has been started with a vision which was given by Dr. Vikram Sarabhai. All of you are well aware of that. And unfortunately, he died very early. The whole program was started with a motto that we want to use space research and technology for the benefit of common man and society. That means people like us, people like you, who are there in the society and to solve their problems as well as the other related aspects. And as I said, unfortunately, Dr. Sarabhai died very early at the age of 52, from 1919 to 1971. And after that, our Prime Minister was searching for an able successor. And that time, Dr. Satish Dhawan, who was the director of Indian Institute of Science in Bangalore, he was chosen. He had just returned from USA those days in 1972. And he took over as ISRO's chairman after that and remained there for almost 13 years. So these were the leaders who gave shape to India's space vision. And all of you know rocket man, Dr. Abdul Kalam. He was our rocket scientist who initiated ISRO's launch vehicle or the rocket program and raised all his history. All of you know about that. And Dr. Kalam served in ISRO for almost more than 22 years. Then he moved to DRDO, then Atomic Energy. He became advisor to Defense Minister and finally advisor to Prime Minister before becoming the President of the country. So that shows his great capabilities as a motivator and a scientist, all put together. And as this is a rare picture, right bottom you are seeing where Dr. Abdul Kalam is discussing something with Dr. Vikram Sarabhai in Tumba. Those days when Tumba was our place where rocket-related activities were initiated by Dr. Sarabhai, while the other application and technology development-related activity was started at Ahmedabad, where I am sitting right now. And as Dr. Sarabhai died early, so after that, his application program was taken over by Professor Yashpal, who was the first director of my center here, Space Application Center. And right now, this is the structure of ISRO. All of you are maybe aware of that. We work directly under Department of Space, which is functioning directly with the ministership of our Prime Minister. There is a Space Commission which governs the policies as well as the other activities of ISRO and its various centers. And recently, this InSpace has been set up, which will facilitate the activities of private sector into space, because government wants that now private sectors would play an important or prominent role in India's space program, which was still now very closed affair, with only government institution like ours participating into that. And a public sector company called New Space India Limited has also been set up along with Antrix, which is already there. So these are our commercial arms of ISRO. And under ISRO, we have the 7 major centers. SAC is one of them, Space Application Center, where I am sitting right now. And there are various other autonomous institutes under Department of Space and many other small centers also. So as right hand side, you are seeing the photograph of each of these places. And as you can see, each place has its own ambience and beautiful working environment at all these places, and all of them are worth seeing. So whenever you get chance to visit nearby places, near say Dehradun or Sriharikota, Trivandrum, Bangalore or Ahmedabad, please do visit our ISRO centers at the earliest opportunity, and you will learn more about various activities happening in our center. Although entry is not that easy, but still we allow visitors at some of these places where the exhibitions are also being arranged regularly. So you can take your chance and visit any of these places. This is our scorecard from 1969 onwards, almost 185 missions, have been successfully flown. And from this slide, it will appear that we have been very successful. But that is not the right picture, because many failures also have been encountered by us. And all of you must have seen that 2019 when we failed to land on moon surface. So that was one of the major setback for ISRO as well as for the whole country. And many of our launch vehicles have also failed. In fact, recently, this right-hand side, you're seeing SSLV. There is a small satellite launch vehicle. Its first version, when we launched in last August, we were very confident that we'll be able to succeed. But unfortunately, it didn't. It worked very well, but it didn't put satellite into the right orbit. So what I'm trying to convey is that failures are part of our program. So we don't get deterred by failures. We learn from the failures, the various lessons learned from each of these failure of whether it is launch vehicle or satellite or payload or landing, all these things we try to find out the reasons for that and try to correct it in the next mission. And you may be happy to learn that after the Chandrayaan 2 last time landing failure, now we are ready with Chandrayaan 3. In fact, today only we had a final design review of that lander satellite, and we are in all purpose we are ready to launch it in second week of July, where you will hear this good news of Chandrayaan 3 getting launched. And after almost 45 days after launching it, we will hear hopefully good news of India or ISRO landing on moon. So this is the overall success card of ISRO. And as I said, we don't get deterred by the failures which we encounter, and space is a risky business, as all of you are well aware of. This is one very proud moment which all of us at ISRO as well as whole India is very proud of, is that when we made this world record on February 15, 2017, when we launched 104 satellites to one PSLV launch mission, PSLV C-37, where 3 of the Indian satellites and 101 satellites from other 6 countries were launched. So this was one of our proud moments, but all world records get broken by somebody or the other. Similarly, this record has also been broken in 2021 by Elon Musk. SpaceX, they had one transporter, one mission, which carried 143 satellites. So our record of 104 satellites now becomes second record instead of the first one. This is Space Application Center where I am sitting right now. And this is the first Earth station built ever in India. So this was India's first Earth station from where we used to do satellite communication. So communication with satellite happened through this Earth station. This is a big antenna, 14-meter diameter, which was Dr. Sarabhai ordered it for fabrication to a Japanese company called Nippon Electric Company. Now it is known as NEC, Japan. So they built this antenna, and this was the first Earth station. And in the whole area of satellite in Ahmedabad, which was almost a jungle those days. Today, if you see, you will not be able to recognize, because it is one of the costliest and the busiest area of Ahmedabad. And today, even in this place itself, where there's only this one building was there in this whole forest. Now today, we have 50 buildings in this particular place, in this main campus of SAC. And we have another 2 more campuses 7 kilometers away from our main campus, which have been developed now. So this shows the development which has happened in 50 years. And incidentally, we just completed our 50 years of existence from 1972 to 2022 December. So this in summary is our place. This is the exhibition entrance where you can visit anytime. It is open on Saturday, Sunday also in Ahmedabad, in our SAC campus. Only on Monday it is closed, and you can have a glimpse of the various activities which we do in Space Application Center. So here, SAC is a unique place because we do what we call the payloads or the sensors, which are actually the brain or the heart of the satellite, and also its application. What Sarabhai told, that we want to do space technology for application. And today I'm going to talk about this communication, navigation application. So that is the area with which this whole program of space research has started in India. And so we are doing what is the originating workhorse of the any satellite, and finally the end product, which is the application. So both these activities are done here at Ahmedabad Space Application Center. So in that sense, our center is one of the unique center, unlike other centers who are doing specific job or specific activity of launch vehicle or rocket or satellite or applications. We do all the activities you can think of. And that is reflected in the workforce or the human resources which we have. We have almost 2,000 people and people from all branches, which is engineering, science, as well as social science also, and from various levels, from technician to undergraduates to postgraduates and doctorates. So all type of people exist here. So we are more like a university or academic institution, like you people. So we have people from all categories, from all skills. We have people, whether it is science, geoscience, physical science, chemical science, biological science, so all type of science, as well as engineering, whether it is electronics, mechanical, computer. So this in summary is the overall profile of Space Application Center. And we work very closely with industries, small and medium enterprises, academic institutions, research institutions, and of course, International Space Agency. And also we have outreach and training program under which we are conducting today this course. Now coming to today's activity or the topic, that is satellite communication and navigation. So in that first, all of you are well aware that Arthur Clarke gave this notion sitting in his laboratory or in his office that we can use, if one satellite can be put at the height of 36,000 kilometers from the surface of Earth, it will be able to provide communication on 1/3 of the globe or 1/3 of the Earth. And similarly, 3 satellites will cover the whole Earth. So with that notion, initially the first artificial satellite Sputnik was launched by Russia in 1957. There was a space race going on between Russia and America. And Russia succeeded to be the first to launch an artificial satellite in 57. And subsequently, Bell Labs in USA built this 1962, this first communication satellite. It was not on 36,000 or the geostationary orbit, but it was in a LEO orbit, low Earth orbit, as it is called, at the height of around 600 to 700 kilometers. And the first geosynchronous or geostationary satellite was launched in 1964, when this particular satellite, Syncom 3, was launched by Hughes aircraft system those days from USA. So this was the first satellite which was set up, and we proved the concept given by Arthur Clarke that we will be able to communicate with one satellite or 1/3 of the globe. And this was the idea which was given by Dr. Arthur Clarke, that you can use geo satellite. Today now MEO and LEO constellation of satellites are also used to do communication. How I will come to that. So this is in summary the or genesis of satellite communication in the world. As far as Indian space program is concerned, Dr. Sarabhai would recognize the importance of communication, and he initiated this TV broadcast via satellite. That was the first program which India started with the application of TV broadcast, because we wanted application to be the prime this thing. And similarly, that's why that first Earth station, what I mentioned, was set up, experimental satellite communication Earth station, ESCAS. The antenna which I showed you, again, another picture of the same antenna, which is a 14-meter diameter antenna built by Nippon Electric Company, Japan. And then we initiated, as I was mentioning you, our main goal was applications. So with this application in mind, we started this program. Of course, Sarabhai gave the idea for that, but unfortunately he died, and then Professor Yashpal took it forward. This satellite instruction TV experiment was conducted by linking 2,400 remote rural villages in 1975. When the American satellite ATS-6 mentioned here was hired by us, by India, to do this TV broadcast. And what was very significant in this was, today you may ask that what is so great in having a TV broadcast? We have DTH satellite at our home and all that, DTH facility at home. through satellite. So what is so great in this? So what was great was that in 75, when even electricity was not available in many parts of our country, 2,400 such remote rural villages were connected to do this experiment of TV broadcast. And after that, since India wanted to build its own satellite also, so we started this uh, program how to learn to use satellite with this application. So this was the satellite telecommunication experimental project STEP in 1977 to 79 time frame. After we completed this site, we started this STEP program where we learned how to use telecommunication using a satellite. That is having a voice communication, the data communication, and all the disaster warning system, radio networking with the VSAT, all these usage we learned, and we had this Franco-German satellite. So a satellite built by France and Germany together, Symphony. So this satellite was hired to do this experiment on communication. So this helped us to learn what is there in satellite, how to use a satellite basically. And after that, we started our own program of developing satellite. And this was our Ariane passenger payload experiment. This was our first geo communication satellite, which was conceived in 75, and we started the TV program. And we took almost 5 to 6 years to build this. In 1981, it was launched. It was conceived in 75, work started in 77 to 1980 time frame. And on 19 June 81, it was launched. And SAC designed this communication payload here at Ahmedabad. And you see this picture of this satellite being carried on a bullock cart. You will see that why not carry in a truck or some other vehicle. People gave the reason that if we travel in bullock cart, the vibration experienced by the payload will be less, so that there is no damage to the electronic circuitry which we have developed where it is being transported from one place to another. So this is how our initial program of communication started, and today we have communication satellites in almost all the frequency bands. You can think of C band, KU, Ka, MC. These are different frequency bands starting from some few hundred megahertz UHF band, 100 megahertz to almost Ka band, means today up to 30, 40 gigahertz. We have satellites in various frequency band. And similarly, in navigation program also, we have different types of satellite in L band and S band, which will give the services which are provided today by GPS. Something similar, our Indian regional navigation satellite or NAVIC, navigation with Indian constellation, that will also provide services to all of you with this NAVIC satellite or navigation payload. And then we have Gagan payload or Gagan satellites, which are used to provide services to Airport Authority of India for aeroplanes for landing and takeoff. So although it has not been operational yet, but very near future, it will become absolutely necessary to use this system by aircrafts all over the world. So this is our satellite program. INSAT 1A was the first satellite in the INSAT 1 series. There were 4 satellites in this INSAT 1 series. 2 worked, 2 didn't work. But this was first time we gave this order. We didn't develop this. We gave order for purchase or development of this radar, this satellite, communication satellite, to American company called Ford Aerospace. So this Ford Aerospace in USA, they developed, designed this satellite. Design was ours, and they fabricated or developed this, and then testing where our engineers also took part. So our engineers did the design, and they took part in training also, the testing part of that also. And we sent many engineers to USA. They learned all the aspects of how to build a satellite. And when they came back here, we set up our own infrastructure, laboratories, other things, so that from INSAT 2 onwards, we are developing or fabricating our own satellites as far as communication satellite. And today we have GSAT series of satellite because we are making that, and we are launching also from our own spaceport, that is Sriharikota. So now we have named it GSAT series. Earlier we were calling it an INSAT series of satellites. So this is how the roadmap of these satellites are. So today we have so many of these communication satellites, starting with INSAT 1 series to now GSAT 24 was our latest satellite. And now we are building GSAT 23 as well as many others, 22, GSAT 23, as well as another new series of satellites for high throughput satellite services. So today we have almost 18 satellites operational in the country, providing more than 250 transponders. Each transponder taken with a bandwidth of 36 megahertz can provide services all across the country. So today we have 18 satellites working in different applications, which provides or take care of the interests of India. This is one typical satellite, GSAT 9, when our Prime Minister suggested that why not we have a satellite which will provide help to our neighboring country also. So that's why we named this satellite South Asia satellite. And initially Pakistan was also part of that, but they created a lot of technical problems while we were discussing the implementation of this satellite. So finally, but Pakistan got excluded from this, and today we are providing services to all our neighboring countries with this South Asia satellite. It was built in record time, and in 2018 we launched it with a life of 12 years. And this was immediately after the launch of satellite on 5th May 2017. Prime Minister organized a video conference with the other neighboring countries. The Prime Minister or President from the neighboring countries, Bhutan, Nepal, Sri Lanka, Afghanistan, and Bangladesh, they participated in this video conference, and everybody appreciated India's gesture or effort of providing these communication services. So now we have set up this Earth station in Bangladesh and Bhutan, and they are using this satellite in a very big way. Other countries also have started using our transponder, but the hub services are provided by us from Delhi. But in future, they also are planning to have their own hub system so that they can do the handling of satellite transponder from their own place. And after that, we had this first high throughput satellite, which is now with higher capacity satellite, which are built for the first time. GSAT 19 was built in 2019, and we launched this satellite with a mass of 3000 kg. So this was built by us and launched from our own PSLV rocket, and then it was taken to the geostationary orbit to transition. And today we have this GSAT 11, which is one of the heaviest satellite ever built by ISRO, which is weighing around 6000 kg. So since our launch vehicle don't have capability, we have launched it from Arianespace French Guiana, which is managed by European Space Agency and CNES, that is the French space agency, and it is owned by a private company called Arianespace. So they provide these services of launch vehicle, which was used to launch the GSAT 11 satellite. And similarly, we have GSAT 6 satellite, which was our first mobile satellite services, where we can have a satellite phone like your normal smartphone. The satellite phone can also work, but instead of terrestrial network, it will use the services of satellite. So in future, we'll have satellite phone and your smartphone getting merged together as a single device. So this is the structure of that. And any satellite communication, it is not sufficient that we launch a satellite. It is also necessary that we have the ground segment or the ground station or Earth station ready, because they provide the hub services. From which place to which place call is to be routed or data is to be transmitted, that all connectivity is decided by the hub station or the Earth station. So Earth station is also very important. And finally, the terminals which are used to communication with at the user place. So that is called user segment. So user segment is also very important as far as this particular service is concerned. So we have built for mobile satellite services 4 types of terminals, which include the satellite phone. This is the satellite mobile radio. This is the satellite phone. Then we have video conferencing, portable terminal, broadcast receiver, and broadcasting terminal. So with which you can do two-way communication using broadcast will receive only, this will be transmit only, while this will be a two-way communication multimedia portable terminal. And this is used for voice communication, known as a satellite phone. And this is the hub station built for each of these satellite which we launch. For that, the hub station electronics is also very complicated. You have antenna, RF system, front end system, followed by baseband systems, which are doing the actual processing of the signals and then routing it from one place to another. So this is how the total network management system at a given Earth station exists. So as I said, ground segment is also very equally critical. And this was one of the recent satellite which we launched where we used higher frequency. As I said, since the bandwidth of the spectrum is limited for each frequency band, so we go from lower frequency to higher frequency. So now we are working with this Ku and Ka band, which are the highest frequencies. And from there, we have to move to what we call optical frequency. So future is going to be in Q and V band. So that's why we did this experiment with this satellite in Q and V band when we linked Ahmedabad with Delhi. So we have our station in Ahmedabad and Delhi. So we use this station to do the communication, as well as we also had a optical communication. So for that, we set up a optical ground station. So that is different from the normal other ground station or Earth station, which we use for RF satellite communication. This is works in an optical domain where instead of RF front end, we have an optical front end, which is the optical telescope is used for doing the communication with the satellite. So this is going to be the norm in future. We will be moving to optical frequencies for doing communication. So these are some of the recent payloads built by Space Application Center, which were launched. GSAT-24 is the very high capacity DTH satellite. So at Tata, we have handed it over to Tata Sky. So Tata Sky is now operating this particular satellite and providing services to people like you. And similarly, this is the latest navigation payload which we launched on 29th May. Just 1 month back, we launched this particular satellite. And now we are going to launch a geostationary camera system, which will be where we'll utilize this antenna. This is a GISAT-2 antenna, phased array antenna, which will be used to do data transmission from geostationary orbit to Earth. So this is the first time we'll be doing that. And this payload we recently made from a small satellite, which was used to track the aircraft. ADS-B is the standard for aircraft tracking. So whatever aircraft move in our airspace, they are regularly tracked by the spectrum monitoring payload, and we get information about all the aeroplanes moving in the Indian region. And today, if you see in the world, till now, we have been doing communication with at a satellite, communication satellite, which is put at a height of 36,000 kilometers, which is a geostationary orbit. Because why it is called geostationary? Because the satellite appears stationary with respect to Earth. Because anything put at 36,000 kilometers will appear stationary, because it also moves with the speed of the Earth's motion, which is at the equator, which is around 0.5 kilometer per second. So that is the speed with which Earth is moving at equator. And the satellite also moves with same speed at the height of 36,000 kilometers. So both of them relatively will appear stationary with respect to each other. So now the trend is, instead of this geo satellite, nowadays worldwide, either people are using mid-Earth orbit or MEO orbit or low Earth orbit or LEO orbit. And MEO orbit is the other, O3b is the other 3 billion satellite, which was launched especially with African continent in mind by an American company. So they provide services in Africa and Asia. And the advantage of MEO is that latency. From geostationary, when you talk, there will be slight delay when voice will be transmitted from the transmitter end and it reaches the receiver end. So when you communicate, say somebody in America sitting in Ahmedabad or India, then you will find there is a slight delay in the reception of the voice. So that is quite irritating when two people are talking with each other. So to avoid that delay, people are going to this MEO orbit and LEO orbit, where because in geo orbit the latency is around 500 milliseconds. Time taken for voice to travel from origination to the destination. It will go to satellite first and come back. So that two-way delay is around 500 milliseconds. So in MEO case, it will be around 125 milliseconds, and in LEO case, it will be around 25 to 30 milliseconds. So that gives the advantage. So you not feel very irritated when you are talking with somebody who is located very distantly. So today now trend is towards, all of you have heard about Starlink satellite built by Elon Musk, and OneWeb satellite, which are built by a company called OneWeb, which is owned now by Sunil Mittal of Airtel. So these two will provide services. There are 700 satellites to be launched by OneWeb. ISRO has also launched recently 36 satellites in one launch. So such two launch we have done. So now already almost I think around 588 satellites are already launched, and only remaining hundreds are yet to be launched. And we'll be providing services for launching of this satellite. Although satellite belong to OneWeb. Similarly, Starlink satellite Elon Musk has built, and he has launched almost 4,000 satellites till now. The plan is to put around 20,000 satellites. So the trend is toward now this type of low Earth orbit moving satellite, and the importance of this satellite can be gauged from the fact that all of you know this Russia-Ukraine war is going on this last 15, 16 months. But still, in Ukraine, Russia has bombarded like anything. So they have thrown bombs at almost all the places in Ukraine, and all the infrastructure, buildings, and telephone network, and TV broadcast towers, and everything has been destroyed or damaged. But still, you'll be surprised to know that TV is also working in Ukraine, and internet is also working. So that is because otherwise it would have been impossible. But with the help of the Starlink services provided through the LEO constellation of satellite, Elon Musk is able to provide these services in Ukraine. So in Ukraine, TV and internet both are working because thanks to this Starlink satellite. So that shows the capability or the importance of satellite communication. And as I said, tomorrow the plan is to have your smartphone work like a satellite phone. So you don't have to worry about the connectivity. Today, whenever you move from one place to another, many places time you find that there is no connectivity and network is not available. So you get very frustrated when you're not able to contact with somebody when you are far off from that place, where in remote areas or rural areas, services are not there. So at that time, your smartphone can seamlessly switch over to the satellite services. So that is how the satellite phone is going to work, and your smartphone itself will become a satellite phone. Today, smartphone and satellite phone are two different you have to carry. Instead of that, your same phone can be used as a smartphone as well as satellite phone. So that type of technology already started flowing in USA. They recently one satellite was launched, Blue Walker. So they are providing these services. So that satellite will have a very large antenna of the size of 18-meter diameter. So all these technologies are going to be there, and in future in India also we'll see that smartphone will become a satellite phone, and user don't have to worry about that particular thing. Now coming to the other part, navigation. We are very proud to say that navigation has almost only originated from India only. That is what is our claim, because the now, which we call the word for boat, that is Hindi word or Sanskrit word now, and now means navigation. So Navgati, that is the Sanskrit word. So our people claim that now or Navgati, that was the origin of the navigation. Of course, there are other versions also. So this is one particular source from where I have taken this. So why navigation is useful or helpful is that it will help us to locate any place in the world. So say if you want to locate my place here, this campus, what is the location? This is the longitude and latitude of this particular building or place. Generally, earlier we used to ask the panwala for finding the way out or for location of any building or any place. Instead of that, now people rely on GPS. So that is what the revolution which has happened technologically, that you don't have to ask anybody. From using GPS, you can find out the location of any unknown place in the world. So this is how that we locate. If you want to locate one point on Earth, you try to first locate the country, then state, then particular city, and then city. When you go, you ask the panwala, and then try to go to that particular place. Instead of that, now GPS can take you anywhere in the world. How it is able to work? That it finally processes these signals which are available from satellite to give you what we call PVT information or PNT information. That is position, velocity or navigation, and time. So minimum you will need 4 satellites. Actually 3 are needed, but fourth one is be used to improve the accuracy of the signal. And since we also want time as one of the output. So we will need one more extra satellite, that is 4 satellites. India has its own program of Gagan and Navik, which is being used for doing the navigation. And this is how, say, why this navigation work? Because say if you want to, any location you want to find out, then you all teachers know very well that we want to find out the X, Y, Z coordinate and the time coordinate. These 4 coordinates, if you want to find out for any place, then what we do is that we try to solve this equation. So for solving an equation with 4 variables, you will need measurement from 4 other entities. So this is how we do. We will need 1, 2, 3, and 4 satellites to locate any particular point on the Earth, because we want time also. That's why 4. Otherwise, only X, Y, Z means 3 also would have been sufficient. So this is how the concept of navigation or triangulation work, using which we do the navigation. And India has this Gagan program, which ISRO and Airport Authority of India started together, where we have developed this satellite-based payload, which is utilized which will improve the accuracy of GPS signal. Because as such, if you try to use GPS signal, pilot tries to use it for landing or takeoff, especially during bad weather conditions, it doesn't provide that required accuracy and integrity, as it is called. So for that, we need extra something for processing to be done, which is done by this payload. And this is how the total system, which has been there. There are 3 satellites which provide this payload. We need a very elaborate ground segment which does the measurement, like our satellite communication ground station. And then you need a user segment which consists of the receiver, which will receive the signals from the satellite. And since India lies in the equatorial anomaly region, so ionospheric effects are very predominant, and it will corrupt our measurement. And the other advantage of Gagan is that these are called satellite-based augmentation system. And the advantage of this system is that because the aeroplane will move from any place to anywhere, it will start from Australia and go to USA, or start from India and go to Europe. So it passes through many countries. So we don't have to put different receivers for each country system. Same receiver will work with Indian satellite also, it will work with American satellite also, or European satellite also, Russian satellite also. So that is the advantage of using this Gagan receiver or the Gagan payload signals. Gagan is a payload in satellite, while the receiver part of that is common, so which is installed in the aircraft. So aircraft need to carry only one receiver, which will work seamlessly all across the world with different satellites. That is the advantage of that. And similarly, we have our own Navik system. As I said, after the Kargil war, Indian soldiers faced a lot of problems. So government decided to set up a committee which suggested that we should have our own navigation system, like GPS. We should not depend on GPS, because GPS resolution and accuracy were not proper when Kargil war happened. So, and some people are suggesting it may be deliberate or by design it has been done. So to avoid all such issues, even though we consider USA is our friend, but still we should be independent of anybody, even independent of our friend also. So that's why this whole program was started in 1999. It was conceived, and 2006 onward we started building these satellites. So today we have these 7 satellites in orbit. In fact, we have built 9 satellites. Latest one we launched on 29th May, where this latest IIRS or Navik satellite was launched. And right now 5 satellites are operational. 2 satellites have some problems. 3 had problem. And the other 2 also we are going to shortly replace, so that we'll have the full constellation. Right now also we can provide services, but with lesser accuracy. And again, it will need elaborate ground segment. And we provide services with 20 and 10 meter accuracy. And it also has a military or specific restricted services, which are available only for strategic user or military user. While the standard positioning or civilian services are available to everybody, all of us, like people like us. So this is the comparison of system. Only one world, only these 5 countries have the full navigation system. Other one, Japan also has its own QZSS system, which is augmenting GPS. So that way, countries have navigation system. GPS from America, GLONASS from Russia, Galileo from Europe, Beidou from China and Navig from India and QZSS from Japan. And if you compare, our system is equally comparable, only our signals are lying in different frequency band. And instead of MEO orbit 20,000 kilometers, our satellite operate at 36,000. This is the two major differences. If you can see our logo here, Navig, is also equally beautiful as the other logos from other countries. And these are the receivers built by us at Space Application Center to capture the navigation signal to be utilized to do navigation like GPS. And if you see the block diagram, whatever we learn as a part of our engineering in electronics and communication, all systems are getting used in this one small chip which goes as a part of your mobile or even as a part of your watch or as a standalone. So the single chip is contains so much information or technology, as it is called, that it is really mind-boggling if you see it. And the cost of this chip is only 70 rupees. So you can imagine the concept, the complicated theory and technology behind this particular chip, which is built for any GPS receiver or Navic receiver, any navigation receiver. So it is so complicated that it has, and these are the other chips which are available for our system. We did a lot of trials at different places in vehicles, and we also gave these chips to our military users, and they also tested it all across the country. As you are seeing the map of India, and everywhere, all across all the places, we have done the experiment of using this Navic signal. And as you can see from the table, although specification was 20 meters, we are able to achieve around 2 to 3 meters of net accuracy, which finally get translated into position accuracy of around 5 to 10 meters. So that shows that our system is equally capable as GPS system of USA. So this whole experiment we did with lot of data collected from all across the country. And we also built receiver for our military users. So these are the receivers which people like us or common people or civilian people will not be able to decipher this signal because they are restricted signal. They are encrypted signal. Means there is some password into that, which only few people will have this password to break this particular system. So that is how this receiver for military user is. And now to show you some application, satellite communication application everybody is well aware of. As I mentioned about TV broadcast, voice communication, then mobile satellite services, then we have our weather forecast from this particular satellite where we have a payload which will give you information about the weather or climate change related to various weather parameters. And then we have telemedicine, teleeducation, about which during COVID time we understand its importance. We're sitting at our place at home also, we are able to communicate with anybody in the world. Of course, it was done through mobile communication or the mobiles, but initially it was started, the whole program was started with a satellite, where satellite was used to do tele-education. So sitting at one place, teacher will be at one place, student will be at another place. And teacher will take, like today I am taking this lecture, it is available to you people through this video conferencing network, but of course through internet. But those earlier days, it was only through satellite that we were able to do this telecommunication. So that is called tele-education. And nowadays it has become very common using mobile technology. And another use is during disasters. All of you know, during disaster time, it is difficult that because our phone gets dead and all sorts of communication get disturbed. So in that condition, what is happening at the remote place, we can know. This is the example of the Uttarakhand Kedarnath disaster. When it happened, immediately after that, our team moved on to Kedarnath and installed this satellite antenna with which we were able to communicate from Dehradun to Kedarnath and from Haridwar, Dehradun, Kedarnath, Delhi, all these places we were able to establish communication within one day. So that shows the potential of the satellite communication. Similarly, immediately afterwards, there was floods in Kashmir, 2013. So that time again, the Raj Bhavan and the CM house at Srinagar was communicating with Delhi or Srinagar to Jammu all these communications links were set up with satellite communications. So our satellite were used very greatly in doing this. So this was the pictures of when our team went to Srinagar immediately. Within 2 days, we reached there and set up this satellite VSAT terminal, which was installed at Governor House as well as Raj Bhavan and CM House. So with that, we were able to communicate from one place to another within Srinagar or outside Srinagar to Jammu as well as New Delhi, so that we can get the guidance, the mentoring from different places, and we can inform about the need of the people who are there, got caught in the disaster. So all these times, the first responders, first thing which will help them is the satellite communication. And as far as navigation is concerned, why navigation is important? Because you may not be aware, but 90 to 95% of activity which you do in your life, they are governed by navigation. They are directly or indirectly being controlled or governed by the use of navigation satellite. So that is another area where importance of navigation. So you can see it has application in almost any area which you can think of. So almost 90 to 95% of activity which you do, including scientific research which we do or military related activities, all things are governed by navigation. And this is how road navigation, transportation, rail, air, maritime, and then defense, various type of navigation system, UAVs or drones nowadays, aerial all weapons are controlled by use of navigation satellites. So you can imagine if you want to shot a missile from here to our enemy country, then the exact location where the missile has to fall, all these things are controlled by position of the missile, which when it start position and the end position. So everything you can control using these GPS satellites. So till now we were using GPS, but now government wants that everything we should replace with our own NAVIC system, because we had, as I said, lot of problems during Kargil war. So after that, now we are not depending on anybody, and we want to use our own system which are under our control for weapon navigation or precise timing application, all type of applications. So this is one unique application. One of our navigation satellite went bad. So what we did was we utilized it for doing messaging service. So because fishermen, when they go in deep sea, they carry their mobile, but these mobile are useless when they are in the sea, because only in coastal region mobile network will come. Otherwise, there is no network in sea. So that time they can get information about where they can get good fishes, if cyclone is coming, then we can inform them 4 or 5 days in advance, because nowadays we know how cyclone is going to proceed. The last cyclone got Bijoy right here, we have seen that its path we have tried to find out, and that is available 5, 6, 7 days in advance. So all this information we can relay to the fishermen with, because fishermen, once they go into deep sea, they remain there for minimum 7 days to 10 days. So during that time, if cyclone is expected, then we can inform them. Similarly, high tide information. If they are crossing international water, if they go towards Pakistan, Pakistan Navy will catch them. Similarly, if they are going towards Sri Lanka, the Sri Lankan Navy catches them and put them in jail. To avoid all such scenario, whenever they cross international water, the alarm will be raised and they get the information that they should not cross this particular place. They should come back. So all this information we can relay through this mobile with putting a small NAVIC messaging receiver, which receives the signal from this navigation satellite, decodes it and gives them via Bluetooth information on their mobile in their native language. So if he is Keralian fisherman, he gets in Malayalam. If he is a Gujarati fisherman, he will get in Gujarati. Similarly, in Andhra Pradesh and other parts of the country. So wherever this, or Tamilian, if he is from Tamil Nadu, so they get their information in the native language, so they will understand it better. Similarly, vehicle tracking is a very important application where all of you know, Ola, Uber, all these things, they use GPS for tracking. So wherever they are standing or where they are moving, all the information, you can get it on a map through this Ola, Uber information, tracking the movement of the vehicle. All these things is a vehicle tracking system. So that is a very standard information. And we also use it for our internal use when we send satellite payload from Ahmedabad to Bangalore. We regularly track it. We to send in, say, if it is sent in truck by road, so we'll track its information within campus. Also, movement of people or vehicle can be seen or controlled by using the vehicle tracking system, which are built using our NAVIC system. Similarly, as I mentioned, this all the strategic information, or whether it is aircraft or naval carriers, UAVs, drones, weapons, all these things are governed by GPS. So instead of GPS, we will like to use the NAVIC. Similarly, gun, mortar, short navigation, all short range, all weapons are controlled by that. Telecommunication network, timing application, all these things, synchronization is done through the timing available from GPS. So that is getting replaced with the NAVIC signals. And similarly, we can do geofencing so that if you broadcast the message, only the people who for whom the message is meant, they will be only able to decode it. So by doing this geofencing, we'll try to find out the area where for which the message is meant, so that will be decoded only in that particular area. Other areas won't be able to see that. Similarly, for surveying application, we have what we call differential GPS. So something similar to differential GPS, we have our own differential NAVIC or differential IRNSS, where there is one reference station, and with respect to that, the rover will move around that 10 to 100 kilometers around that area. So sitting at that around the region of 100 kilometers, we can do measurement with the accuracy of normal GPS or INSS NAVIC accuracy is around 5 to 10 meters. That can be increased to up to centimeter or even millimeter level by using this differential, because it will cancel out the errors which are there. When you do any differential measurement, so we have this differential measurement which will help us to cancel out the errors, so that will improve the overall accuracy to centimeter or millimeter level. So we used it to during testing of landing of Chandrayaan 2 lander on Earth. When we were testing it, we used this particular system to find out the exact information about the landing. And similarly, this is how the whole country, this referencing can be done, so that the surveying part can be taken care of with very high accuracy. So each building, each farmhouse, each place in the country will be mapped using this RTK receiver, and with the precise accuracy of centimeter level, because the cost of land is very high per hectare or per acre. Cost is very high when you buy any land in city. So each centimeter will matter. So the costing and all will need perfect measurement of the land plot or the farmhouse or any other building or any other. So that is being done with the surveying method, which will use GPS nowadays. But instead of GPS, we use the differential GPS technique. Same way, differential NAVIC technique. And there is our mobile satellites, as I mentioned, GSAT-6 satellite, which was launched by ISRO for mobile satellite service. So we now have applications which are combination of navigation and communication. So we can find out the movement of our CISF or BSF or CRPF forces or army moving inside the jungle, because you know about the Naxal problem, because Naxalites are there at many places in Madhya Pradesh, in Jharkhand, Chhattisgarh, all these places, Naxalite or Telangana, the Naxalite problem is very prominent. So to take care of that, when the armed forces move inside or paramilitary forces go inside the forest, the movement of that is continuously tracked sitting outside a base station, which is outside the forest, or even from CRPF headquarters in Delhi, they can monitor the movement of the troops inside the forest. So that is one area where we are working on with the combination of navigation and communication. Then we have, what we have done is that all Rajdhani and Shatabdi Express are now converted with these NAVIC and communication terminals. So we carry them inside these. They are all located inside each locomotive of the Indian Railways in Shatabdi and Rajdhani Express, and the movement of the trains is tracked continuously when it moves from one place to another. And the accident which happened recently we can avoid such type of accidents if we have this navigation and communication based system installed in each of these trains, so that their movement can be monitored and automatically traffic control can be administered. So right now we have not done it. We are doing it all manually or with the centralized system, but future will be, we will regularly monitor the movement of trains, and that will be utilized to control the traffic or the movement or signaling method of the trains or track movement. So that will help us to avoid such accidents in future. Similarly, boats moving, as I already gave the example of fishermen going into sea, those all sub 20-meter boats are fitted with this type of communication and navigation terminals, which will help us to track the movement of boats. There are around 4 lakh fishermen, 4 lakh boats in the country, which is of the size of 20-meter or less. So all movements of these 4 lakh boats regularly is being tracked by Indian Navy from one place in Gurgaon. So they will be able to continuously find out. And the problem like what happened in Bombay when the Pakistani boat entered and the terrorists came in that boat and nobody noticed it. So now that any foreign boat or alien boat will be discovered by us, because our boats will be fitted with the terminal. The foreign boat will not have our terminal. So we'll be easily able to locate them and find out from combination of satellite communication, navigation, and remote sensing images. So we have carried out a lot of experiments in all type of ships with our NAVIC system, and it is working very fine. And we have already got the certification from International Maritime Organization (IMO) for using these particular terminals of navigation receiver in any type of ships. So they will be now carrying with this IMO certification. And similarly, all our Earth station, from where we launch satellite in Sriharikota or track these satellites through our district terminals in Bangalore or at various places in the world, they are all now synchronized with the timing signal available from our NAVIC system. Earlier, they were all synchronized with GPS signal, and GPS in turn is synchronized with our India standard time. So this all synchronization is now getting shifted to our own NAVIC system. So that's why importance for timing also is very, very. And similarly, we have developed this NAVIC-based timing receiver or clock, which gives us a very precise timing with respect to Indian standard time. So all these things are now regularly being used. We have also done synchronization with power system, because whenever war happens, first thing enemy will attack is your power system or power grid. So if power supply is disturbed in a country, everything will get disturbed during war. So to avoid that thing, right now everything is synchronized with GPS signal. We did this testing with our own NAVIC signal, and it is exactly matching. As you can see from the graph, they are exactly matching with each other. And we are providing this timing signal. You can visit our site sac.gov.in, and you get this NTP timing with which you can synchronize your computers also. So we are doing this NAVIC time dissemination, where all the computers in our country will get synchronized with the single timing reference. So whenever you switch on computer, although it shows time, these times are not synchronized with each other. Each computer will show with its own RTC clock, its own timing, although they look almost same, but to millisecond or microsecond level, they are not synchronized. So that all we can do by synchronizing your computer with the timing provided by us through this our website, NAVIC application timing and tracking. So you can visit this website and you get this NAVIC timing, which you can source, and then you can synchronize it with your computer. So your computer will get locked with the NAVIC timing. That is the advantage of this. Similarly, when you go to beach for swimming, there are some areas which are highly prone for drowning. So to avoid such thing, we have installed this NAVIC drifter. Drifters are floaters which float into the water, and they regularly provide information. This information is collected by a tourism site, and they give regular advisories that this part of area is very prone to this rip current, so that there is a chance of drowning is high in this place. So these tourism companies and all, they are taking advantage of this information, where instead of GPS, now we are using NAVIC to locate the exact location where such rip currents are flowing. Similarly, through balloon, we do a lot of measurement of our atmosphere, whether it is temperature, humidity at different levels. So we float a balloon. Balloon goes from ground to almost 20, 30, 40 kilometers in space. So during that time, it will collect data. So this data is getting locked into this particular logger, and that balloons are used to do the time stamping and give the information about humidity and all this temperature and all this, which are regularly used to feed into the weather forecast of our country. Similarly, Aadhaar enrollment now many times because of the illegal immigration, where the actual Aadhaar card entry has happened, that all we get time stamped by the location as well as timing. So that all information will be now NAVIC based. Earlier it used to be GPS based stamping of timing and location. So instead of that, now our NAVIC is being used, and recently Aadhaar has now decided that we'll be, wherever these Aadhaar centers are there, we will use the NAVIC receiver to stamp the location of that center as well as the timing, so that any outside people don't enter inside India and get registered as citizens. Now, initially when we started this work, our launch vehicle was using GPS receiver. So there also we have now PSLV and GSLV. We have replaced this with a NAVIC plus GPS. So it will receive signal from both side of the 180-degree apart of both side of the rocket, and it will collect both GPS and NAVIC signal and come out with a solution to give exact position of the rocket and the satellite when it goes from Earth to space. So that is another thing. Then similarly for Gaganyaan program, we are doing this paired abort test. So whenever in emergency the mission is to be aborted, the astronaut are to be taken out of that. So their movement will be all monitored of the ejection module, escape module will be monitored through this and combination of navigation and satellite communication. Similarly for Air Force, we did these trials on aircraft. So both transport aircraft as well as fighter aircraft are fitted with this NAVIC receiver, and they used to find out the exact location of the aircraft movement. So aircraft movement, then landing on airbase or airport, all these things with got accuracy, it is able to do it. All this information is collected using the SATCOM and navigation terminal. So this is the NAVIC based aircraft tracking system, the practical which I showed you there. And these are the applications about which I mentioned, that how we can use this lecture. So similarly, tracking of these boats, movement of aircraft, movement of ships. So everything we can do using this combination of communication, navigation satellite. Then somebody wrote to Prime Minister that our soldiers are dying in Siachen Glacier and we are not able to locate their bodies even. Forget about bringing them back to their family. So the battalions of soldiers, they go there for 3 to 6 months. So we'll track the movement of the soldiers sitting here in New Delhi or in Srinagar, and regularly their movements are being tracked. The only challenge here is that in Siachen, the temperature is around minus 55 to minus 60 degrees, very cold temperature. So in that temperature, and the system has to work, there is no provision of charging the battery. So battery has to work, but then battalion goes there for 3 to 6 months. For 3 to 6 months without charging, that has to work, that battery, in minus 55 to minus 60 degrees centigrade. And it should provide information about the location of the soldiers. And it should be very lightweight. So we have to make it like a watch, because soldier cannot carry a big terminal or the big instrument. Even smartphone or type of instrument also it cannot carry, because he has other things to carry with him about his ration and other things. So to avoid all that thing, we have tried to develop a miniaturized version, battery operated, which will last for 3 to 6 months and work in that very cold environment. Similarly, we have developed a navigation system which will work in hilly terrain area, when hill station or hilly areas where it is difficult for aircraft to land. So that time we set up a local system to help them to land. And ultimate will be the Navic in your mobile, like GPS is there in your mobile. There is plan to bring in Navic also. Already it has started coming in some of the high-end mobiles and middle level, but we want it even in a feature phone. This Navic in mobile facility should be available. In China and Russia, there is a law that if you are in China, you have to use their system instead of GPS. Similarly, in Russia also, GLONASS is to be used. You can use GPS in China or Russia, but your mobile has to be GLONASS enabled or Beidou enabled. Similarly, we also want in India that your phone should be Navic enabled. You can use GPS. So these are some of the brand models of mobile where already the Navic is available and you can utilize the services of Navic where using which. And nowadays trend is towards using all these signals from all the navigation system to find out location of any place. And we are augmenting this Navic system. So instead of 7 satellites, we'll have 11 satellites in future. So 4 more satellites are going to be launched. 3 bad ones are getting replaced. 1 we have already replaced. 2 more will be replacing. And 4 more will be launched. So totally it will be 11 satellite configuration, which will provide services. And finally, Gaganyaan. All of you know we have started this Gaganyaan program. Although earlier Rakesh Sharma or Kalpana Chawla, Sunita Williams, they have all gone in space. They were Indians. They are Indians. But of course, they have gone in a foreign satellite or foreign mission. So instead of that, Prime Minister announced in 2022 that by 2019, that 2022, when it will be our 75th birthday, we will launch a Gaganyaan. But of course, COVID came and we could not fulfill that. But we are already on the job, and within next 2 years, we'll be launching this Gaganyaan program where an Indian will go from Indian soil into in an Indian yan or Indian satellite into space with an Indian launch vehicle, and then come back on Indian soil, either at Veraval Coast or somewhere in Bay of Bengal or Arabian Sea. So we are not decided where finally it will land, but the launch will be from Sriharikota. It will be taken into space, remain there for 2 to 7 days, and then come back on Earth on an Indian soil. So that is how it has been planned. So this will be this crew cabin of Gaganyaan. Already you would have heard about that in our human space flight lecture. So now today we have all the technologies. This launch vehicle is available. The satellite service module is a satellite which is available. The crew module is like a room where we are sitting right now. So there will be 3 astronauts maximum can sit there, and that will be mounted on the service module. And this payload or satellite will be taken on this launch vehicle and put into space. And as I said, it will remain there for 2 to 7 days and then come back on Earth. So total weight is around 7 tons, 7,000 kg. You can imagine all the subsystems and systems which we have put. So till now, ISRO has been developing all technologies, engineering and technology. We are masters of that, but we have to now change some orientation to human-centric because safety of person is important. So like when you travel in aircraft, something similar when you travel in spacecraft, safety of the people should be paramount and not technology. So we are trying to work from engineering-centric to a human-centric approach. An astronaut will be wearing this space suit, and like these 3 seats will be there for them to sit like in an aircraft. Similar way in spacecraft also we have these 3 seats. And another major requirement is 100% communication. So again, satellite communication is very important here. So we are going to launch 2 more communication satellite, IIRS. So Gaganyaan, because Gaganyaan will be moving across this world. So only 2 times in the morning, 2 times in the evening only it is visible in India. Rest of the time it is moving into other places. So during all this time, we want to remain in 100% communication, means by email, by internet, by voice, by video, for all means we want to use to with the astronauts sitting in Bangalore. So that is possible only if we have 100% communication. So for that, 2 more satellites. So Gaganyaan will communicate with the geostationary satellite, which in turn are constantly looking towards Bangalore. So that way we'll achieve 100%. We'll also hire ground station from other countries because whenever it is moving in other parts, we should need a redundant system for communication. So through this collaboration with other countries or stations, And these 2 satellites, we are trying to achieve 100%. With all available resources based on today, we can achieve only 40% connectivity. So from 40, we have to move to 100. That must 100. It is a major requirement of a Gaganyaan mission. Finally, we are hearing of a lot of frauds happening in your financial transaction, communication, all these things in share market and all. So to avoid such thing, why these frauds are happening, to avoid that, we have done an experiment called quantum frontiers. So quantum communication, where your password or the OTP, which normally you get on your mobile from bank or somewhere else, which is used to decrypt the signal or do the transaction. So that will be now transmitted through a quantum channel. The other data will go through your normal fiber optics or the RF channel through space. But the quantum channel will take this password or the OTP. So because that data is very less, so that can be easily transmitted using photons. So photons which are available in light, something similar photon from laser will be utilized to do this communication from one place to another. So we did this experiment in Space Application Center from one building to another in space. We carried out this experiment of sending the password. So this password was coded again through these photons. And the advantage of photon is that anybody tries to hack it or do the theft of that, it will be immediately the communication will stop. We will come to know that somebody is trying to steal it. So communication will automatically stop, and that will help us to eliminate this hacking of our system. So this is how we did experiment from one place to another in our campus, 300-meter apart located, and we completed this experiment between these 2 buildings. This is our campus here in Ahmedabad. And we could successfully use this transmission of OTP word. And the plan is in future we will be putting 3 satellites and 2 ground stations, which will help us to do this communication. And then finally, the plan is to cover whole India with this type of hybrid network system, where your password will go via this quantum channel or photon channel, and the other data will move like a normal channel. So this is how we can work on this quantum communication, which will help us to avoid this problem of hacking and all the cyber frauds which are happening today. So instead of your OTP coming on your mobile through your normal GSM network, it will now come through the quantum channel. So by next 30, 50 years, we will see this revolution happening and everything will change. Everything will become very secure community. So in the end, these are the various opportunities which are available if you work with Space Application Center, navigation, science and technology, satellite communication, and remote sensing. We have not talked about science and remote sensing today, only navigation and communication. We also support a lot of student activities. So students can take part in our outreach and training activity. Even for teachers also, we organize regular training through webinars, or they can bring the children, students here to visit our places, our exhibitions, and we help to organize space clubs, space events, space merchandise. The space tutors are getting appointed all across the country. And the basic idea is to encourage study of space science or space related activities, whether it's navigation, communication, or many other things, and to help in student internship and training programs. So a lot of activities, of course, exhibition at our place as well as mobile exhibition at various places. We go to various schools and organize these exhibition events also. So you can write to us, to director of each of the center, and we'll help to organize. We send our teams for arranging lectures and arranging exhibitions of various space related activities at your school itself. So this is our exhibition place where you can come and have a look at whatever I have told today. Apart from that, many other things which we are doing. We also organize course for UN Center like this, like communication, navigation. We have separate courses getting organized for 9 months, and then they can get MTech degree also if they complete the project work. You can get more information about all our ISRO activities from various books, exhibitions, then various material available on internet and other places. So in summary, we are doing a lot of activities related to communication, navigation, remote sensing, science, which helps people, whether it is tele-education, telemedicine, health monitoring, monitoring the resources of the earth, monitoring resources of like water, land, agriculture, many things. Disaster time, we play a major role. So all in all, these are our leaders who have become chairman of ISRO and handle the activities or guided the activities of ISRO during all these 69 years, almost 53 years since 1969. After initially Sarabhai gave this whole concept, of course, as I said, he died very early at the age of 52. So that was a great setback for all of us. Otherwise, and the major reason why ISRO is doing well is because of team spirit. We do it all the work as a part of team. So it is a teamwork. It is not any individual, myself or chairman or anybody. They are not responsible. So all of us are responsible for doing all the activity. So team spirit is important. We work with very high integrity, motivation. Even women also, we provide equal opportunities to everybody. So that is another major hallmark of ours. Whatever budget has been provided by government to us, we try to work within that limits and complete our activities with great motivation. Even if problems are there, we can use even bullock carts and cycles to carry our work. So thank you all for your listening.